Well, good morning. This meeting will come to order. Pleased to welcome our panel of witnesses here this morning. As you may recall, during our committee markup at the end of June, Chairman Gordon committed to holding a hearing on the topic of liquid fuel production from coal. And I'm pleased that we're able to host such an expert panel of witnesses today to discuss the barriers and benefits of using our abundant coal resources to produce liquid transportation fuels. I understand that many supporting the coal-to-liquid technology do so at least in part because this technology could help to decrease oil imports. There's no question that we must reduce our reliance on foreign oil supplies, and I've worked to ensure the federal government continues to play a critical role in the development of bio-based fuels as an alternative to petroleum for transportation fuel. Achieving greater energy independence will take collaborative work from a range of experts. We need to fully explore all of our options for diversifying our fuel use. I sincerely hope that the urgency to achieve greater fuel supply diversity, energy independence, and fuel use efficiency will not lead us to turn a blind eye toward the pressing issue of global climate change. We have a need to have a comprehensive strategy to build an energy future that is sustainable. And I recognize there may be economic and strategic benefits of advancing coal-to-liquid technologies from both the regional and the global perspectives. I'm also interested in learning more about the possibility of combining coal with biomass to produce liquid transportation fuels. I further understand that converting coal into transportation fuels helps reduce the emissions coming from our tailpipes. However, I'm also aware that there are significant environmental changes associated with using coal to produce liquid fuel. I believe it's essential that we continue to examine our energy strategies with attention to the issue of global warming and other environmental concerns such as management of our water resources. I'm also interested in the price implications of creating a second market for coal that will compete with coal's use in electricity, in the electricity generation, and in the projected lifespan of our coal reserves. We can't build a coal-to-liquid industry overnight, nor should we fully embrace coal-to-liquid technology as part of our energy strategy until we have thoroughly examined all of the relevant concerns and plotted our next steps sensibly in a manner that puts our federal resources to good use. Again, I'd like to welcome our witnesses and say that I look forward to your testimony and your recommendations for the committee. At this time, I will yield to my distinguished colleague from South Carolina, our ranking member, Mr. Inglis, for an opening statement.
Chairman, I appreciate the opportunity to participate in this hearing. And this afternoon, Coca-Cola and the United Resource Recovery Corporation will be announcing their intent to build in Spartanburg, South Carolina, the largest bottle-to-bottle recycling plant in the world. The plant will recycle 100 million pounds of plastic for reuse each year, enough plastic to make 2 billion 20-ounce Coca-Cola bottles. That's a lot of Coke. The plant will bring jobs to the South Carolina's 4th District, require less energy than producing bottles from unused materials, reduce waste, and lessen carbon dioxide emissions by 1 million metric tons over the next 10 years. It wasn't long ago when the best way we knew to deal with waste from bottles was to dig a hole and bury it. When we found out that strategy wasn't the best use of resources nor environmentally sound, we innovated and started recycling. I suppose when we first started realizing the negative effects of burying our plastic, someone could have and may have suggested we just bury the waste in a different place, maybe at the bottom of the ocean. In retrospect, it's easy to see that approach, while newer looking, was equally problematic. So plastics are everywhere, and we learned how to innovate. In the same way, coal is a fact of life in our current energy situation, and we have an opportunity to innovate to make it the most efficient use of that resource. And coal is a lot like those plastics. At one point, we thought burning it in kettle stoves, was a good way to heat a home. Now, the challenges of carbon emissions and greenhouse gases cause us to rethink that strategy. I'm concerned that we may be headed down the wrong track here in gasifying coal for transportation use. Makes a lot of sense to use that coal, for example, in integrated gasification combined cycle technology that's stationary and that makes it so we can produce electricity and then use that electricity in things like plug-in hybrids. And that we can also generate hydrogen power out of similar use of that technology by capturing the hydrogen. But I have significant concerns about whether this is the right path to make it into a liquid and make it a portable transportation fuel. Seems to me that there are other portable transportation fuels. We can't put a reactor in our trunk, and we can't clamp a windmill on the back bumper. So we got to find some portable energy source for our cars. And perhaps I could be convinced that coal to liquid is a good idea for transportation purposes, but I come with great skepticism about whether it would work or whether it's desirable. So I look forward to hearing the testimony, and Mr. Chairman, I yield back.
Thank you, Mr. Inglis. If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. Oh, Mr. Hall from Texas, who would recognize you for 5 minutes, the ranking member on the full committee.
I'm sorry, Chairman, to be late, but I did want to give an opening statement. I was trying to read it one time before I gave it. But,
did you make it?
Not quite.
All right.
I'd like to thank you for having this very, very important hearing today. You and I are both from energy states, and we have similar ideas about it. I hope we can get together. I've stated a lot of times that coal is an important part of our domestic energy mix, and that it should be, and certainly should be continued to be so through broadened use, in particular coal to liquids. One of our witnesses, Dr. Bartis, states in his testimony that OPEC revenues from oil exports are about $700 billion a year, $700 billion. Now, we're handing countries like Venezuela, Iran, Libya, Saudi Arabia, hundreds of billions of dollars a year. Why? Well, because unfortunately there are those in this country that feel it's better to give $700 billion to unstable foreign governments than it is to invest in our own country, our own workforce, our own national security, and our own national independence. And so today we're talking about coal to liquids technology, of which I've been supportive in this and previous Congresses. Just this year alone, we've attempted several times to include common sense language to bills that have passed through this committee and onto the House floor, language that is in fact supported by some of our witnesses' testimony, but all of which was ultimately defeated. I know that we have to worry not only about energy supply, but also about the effects of energy exploration, production, and consumption on our own environment. I have faith in our scientists and inventors that they'll devise ways to increasingly reduce emissions from the energy life cycle of fossil fuels. We have to have fossil fuels. It's ridiculous to think we're going to do without them, or we're about to do without them. If we can invent ways for humans to live in space, we can continue to improve the capture and sequestration of carbon dioxide and other greenhouse gases. I've said it before, we should use all domestic resources to arrive at energy independence. We need renewable energy and plug-in hybrids, but we also need clean coal technology, nuclear power, and environmentally responsible exploration and drilling for oil and natural gas on American soil and in American waters. While we continue R&D into renewable fuels and alternative vehicles, we still need fossil fuels in order to maintain the lifestyle that we Americans deserve and that makes the United States of America the greatest country in the world. The alternative is sending our young overseas to take some energy away from people when we don't have to. We have plenty right here at home. Thank you. I yield back my time to a good chairman.
Thank you, Mr. Hall. You did a good job.
Would you like me to read it again?
Well, the second time could get better, huh?
I do really thank you.
You're welcome. We thank you. Now, I can say that if there are other members who want to enter something into the record, you may do so, and we'll be done at this point in the record. At this time, I'd like to introduce our witnesses. We have Dr. Robert Freerks, Director of Product Development with Rentech Corporation. Dr. James T. Bartis is a senior policy researcher at the RAND Corporation. Dr. David G. Hawkins is the director of the Climate Center at the National Resources Defense Council. Dr. Joseph Romm is a senior fellow with the Center for American Progress. Dr. Romm is also former acting assistant secretary to the Office of Energy Efficiency and Renewable Energy during the Clinton administration. Dr. Richard D. Boardman heads the Secure Energy Initiative at the Idaho National Laboratory, Department of Energy. And I was looking for my friend from Utah, Mr. Matheson, to introduce our last witness, Mr. Ward, but Mr. Matheson didn't get to come in and say nice things. So Mr. Ward, John Ward, is the Vice President for Marketing and Governmental Affairs at Headwaters, Inc., and we welcome all of you. Our witnesses should know that spoken testimony is limited to 5 minutes each, after which the members of the committee will have 5 minutes to each ask questions. And we will begin with Dr. Freerks.
Thank you. Good morning. I am Dr. Robert Freerks, Director of Product Development for Rentech. I'm a synthetic organic chemist with 26 years experience in the science of fuels, and for the past 8 years I've been working on producing synthetic jet fuel and diesel fuel utilizing the Fischer-Tropsch process. Rentech is one of the world's leading developers of Fischer-Tropsch technologies with 25 years experience building and operating 5 plants. Our plant designs are a straightforward application of proven commercial components. The process first takes any carbon source, gasifies it to produce syngas, which is fed to a Fischer-Tropsch reactor, and the raw FT products are processed into chemical feedstocks, diesel, jet fuel, and naphtha. The process captures CO2 and other contaminants at several stages. FT can be a significant element of the solution for the dual energy challenges facing America: dependence on imported crude oil and the need to reduce our greenhouse gas emissions. Given the abundance of domestic feedstocks and the proven track record of the technology, FT fuels can greatly help reduce oil imports, and Rentech will lead the way. Along with our commitment to energy security, Rentech is dedicated to reducing greenhouse gas emissions. CO2 capture is inherent in the Rentech process, so the only obstacle to significant carbon emissions reductions is sequestration. Rentech is teamed with Denbury Resources, a company that is leading the way on CO2 sequestration and enhanced oil recovery. When used for EOR, CO2 from the production of 1 barrel of FT fuel yields an additional barrel of oil from marginal oil fields, resulting in a 2-for-1 domestic energy benefit. Rentech fuels are the cleanest liquid transportation fuels available. As you can see from the containers in front of you, the fuels are clear, they smell like wax, they contain essentially no sulfur and aromatics, they are non-toxic, biodegradable, and completely compatible with the fuel distribution system and engines. The DoD, a leader in this area, has found FT fuels to meet virtually all of their environmental and performance requirements, including significant particulate matter reductions, up to 96%, reduced CO2 emissions, and higher performance in advanced aircraft. Last month, the Air Force certified its entire B-52 fleet to run on a 50-50 blend of FT jet fuel with conventional jet fuel, and we look forward to 2011 when that certification is extended to the entire fleet. Today, the barriers to building large-scale coal and petcoke-fed FT facilities are purely financial. Oil price volatility continues to discourage potential FT investors. Congress should enact policies to help reduce risk and encourage investment in these plants. And I refer to my written statement for our recommendations, including a regulatory and legal framework for CO2 sequestration. Also, as our nation enters into a regulatory regime for managing CO2 emissions, it will be critical that the system established to account for man-made CO2 is beyond reproach. This committee should take the leadership role in forcing the development of a modern, comprehensive, and universal model for assessing the life cycle greenhouse gas emissions for all fuels. Such a life cycle analysis should consider the latest production technologies and processes, the energy inputs throughout the production of the raw material and through the distribution to the point of sale, including those of imported oil and other fuels and the emissions associated with their use. What I have discussed so far is the current state of CTL technology. What I want to discuss next is the future. As I described above, the first step in our process is gasification of the feedstock to produce syngas for use in our FT reactor. Rentech is in the early stages of developing the next generation of our process, biomass to liquids. Unlike CTL, which has been utilized commercially for decades, commercialization of BTL faces near-term hurdles. Current biomass gasification technology is not nearly as advanced as that of coal gasification. Most manufacturers are just now investigating the ability of their systems to accept biomass along with coal. Advancing new biomass gasification and co-feed technologies could be greatly expedited with federal support. Biomass gasification works, and it is our objective to integrate it into our production process in progressively increasing percentages. But for a company such as Rentech or any of the other U.S.-based FT fuel developers and their investors, such risks are not financeable at this time. Congress can help advance the technology of BTL through the establishment of a loan or grant program to allow commercial operators to acquire gasifiers that can be dedicated to testing various forms of biomass over extended periods and growing seasons. Once biomass has been proven as a viable commercial feedstock for FT plants and the plants are connected to carbon sequestration opportunities such as EOR, as is our Natchez plant, then it is entirely realistic to envision a process that absorbs CO2 from the atmosphere and stores it underground. This would move transportation fuels and coal from being a producer of greenhouse gases to being a net part of the solution. We view this as the game changer, not only for Rentech, but for our nation. Thank you very much for the opportunity to address the subcommittee today, and I look forward to answering any questions.
Thank you, Dr. Freerks. Mr. Ward?
Thank you, Mr. Chairman. Members of the committee, I'm John Ward, Vice President of Headwaters Incorporated, on whose behalf I'm testifying today. I'm the immediate past president of the American Coal Council and also serve on the National Coal Council as appointed by the Secretary of Energy. Headwaters is a member of the Coal to Liquids Coalition, which is a broad group of industry, labor, energy technology developers, and consumer groups. This coalition is interested in strengthening U.S. energy independence through the greater utilization of domestic coal to produce clean transportation fuels. Now, the prospect of making liquid transportation fuels from America's abundant coal resources has received significant attention in recent months, and as with any high-profile policy debate, this means many misconceptions have arisen. It may be best at this point to summarize what coal to liquids is by pointing out what it is not. First of all, coal to liquids is not a new kind of fuel. Any liquid fuel product that can be made from crude oil can be made from coal. Products from coal to liquids plants include high-quality gasoline, diesel fuel, and jet fuel. It can be used in the existing engines without modification to those engines, and can be distributed through our existing fuel distribution systems. Second of all, coal to liquids is not dirty. In fact, fuels produced by today's coal to liquids processes are exceptionally clean when compared to today's petroleum-derived fuels. Coal to liquid fuels contain substantially no sulfur. They also exhibit lower particulate and carbon monoxide emissions. These fuels also contribute less to the formation of nitrogen oxides than petroleum-derived fuels, and they're readily biodegradable. As for greenhouse gas emissions, coal to liquids refineries generate carbon dioxide in highly concentrated form, allowing for carbon capture and storage. Coal to liquids refineries with carbon dioxide capture and storage can produce fuels with life cycle greenhouse gas emissions profiles that are as good as or better than the petroleum fuels that they replace. And finally, coal to liquids is not strictly a research and development effort. The term coal to liquids refers to a broad class of technologies for making liquid transportation fuels from coal. Many of these technologies have been known for decades. Many are being deployed at commercial scale in other parts of the world. And likewise, carbon capture and storage technologies are currently being practiced at commercial scale for enhanced oil recovery operations in many locations around the globe. Now, as the federal government considers measures to support coal to liquids, it's important to provide two different types of support. First, commercialization incentives are needed to speed the commercial deployment of coal to liquids facilities in the United States with the goal of increasing our nation's energy security. Second, research support is needed to continue to improve the efficiency and environmental performance of coal to liquids technologies with the goal of making this already clean resource even cleaner. Specific areas where continued research and development support would be beneficial include, number one, utilization of biomass as a strategy for reducing greenhouse gas emissions. Number two, improving life cycle assessment tools for determining greenhouse gas emissions profiles for coal to liquids facilities when compared to other fossil fuel energy sources. And number three, expanding methods of carbon capture and storage beyond the currently available opportunities in the area of enhanced oil recovery. The advantages to developing a coal to liquids capability in the United States are numerous. Some of the dollars we now send overseas to buy oil would be kept at home to develop American jobs utilizing American energy resources. We would expand and diversify our liquid fuels production and refining capacity using technologies that are already proven. We would produce clean burning fuels that can be distributed through our existing pipelines and service stations to fuel our existing vehicles with no modifications to their engines. We would take a real and immediate step toward greater energy security. Thank you for the invitation to testify and your interest in this important topic. I'd be happy to answer any questions.
Thank you, sir. Dr. Bartis.
Thank you for inviting me to testify. United States oil consumers are currently paying about $500 billion per year for crude oil. Most of that amount ends up being paid for by households, either directly or in higher prices for products and services. The bill averages to almost $5,000 per household per year. Moreover, the large amount of wealth transferred on a global basis from oil consumers to oil producers raises serious national security concerns because some, although certainly not all of this revenue, is being spent contrary to our foreign policy interests. But no less pressing is the importance of addressing the threat of global climate change. For example, without measures to address carbon dioxide emissions, the use of coal-derived liquids to displace petroleum fuels for transportation will more than double greenhouse gas emissions, and this is clearly not acceptable. The emphasis of our research at RAND on unconventional fuels has concentrated on what is known as the Fischer-Tropsch coal-to-liquids method. We find this option to be the only unconventional fuel option that is commercially ready today and capable of eventually displacing millions of barrels per day of imported petroleum. Reducing large amounts of unconventional fuels, including coal-derived liquid fuels, and moving towards greater energy efficiency will cause world oil prices to decrease. Our research shows that under reasonable assumptions, this price reduction effort could be very large and would likely result in large benefits to U.S. consumers and large decreases in Opec revenues. We have also examined whether a large domestic coal-to-liquids industry can be developed consistent with the need to manage carbon dioxide emissions. If we are willing to accept emission levels that are similar to those associated with conventional petroleum, the answer is definitely yes. One technical approach for achieving parity with petroleum is the capture and sequestration of the carbon dioxide generated at the plant site. A second approach involves using a combination of coal and biomass, as we just heard. Fortunately, the second approach is very low risk, although not quite ready for commercial production. Now, given the large demand on OPEC oil that we anticipate will persist over the next 50 years, this is a very good answer. We can at least address a major economic and national security problem while not worsening environmental impacts, at least on the global scale. If, however, we demand a significant reduction in emission levels as compared to conventional petroleum, the answer is a qualified yes. The only way we know of reaching this level of carbon dioxide control when making coal-derived fuels is to use a combination of coal and biomass as the feed for the plant and to capture and sequester most of the carbon dioxide generated at the plant site. The reason I give a qualified yes is that there does remain considerable uncertainty regarding the viability of sequestering carbon dioxide in geological formations. Against this background of benefits and challenges, federal R&D has an important role to play. Foremost in priority are multiple large-scale demonstrations of carbon sequestration. Our analysis shows that the limiting factor in the growth of the domestic coal-to-liquids industry will be the time required to determine whether and how hundreds of millions of tons of carbon dioxide can be annually sequestered. The remainder of my recommendations follow from what we at RAND describe as the middle path to coal to liquids development, namely a path that focuses on reducing uncertainties, fostering early but very limited commercial experience, and reducing greenhouse gas emissions. First, Congress should consider providing federal cost sharing for a few site-specific front-end engineering designs of commercial plants to convert coal to liquid fuels so that government and private investors have better information on production costs. At RAND, we have learned that when it comes to cost estimates, as it's often the case that the less you know, the more attractive the costs. Second, Congress should consider establishing a flexible incentive program capable of promoting the construction and operation of a few early coal-to-liquid plants by our country's top technology firms. These early plants can also serve as demonstration platforms for carbon capture and sequestration and the combined use of biomass and coal. Third, the current energy R&D program on transportation fuels in the Department of Energy is too narrowly focused on hydrogen and ethanol from cellulosic materials. This program needs to expand to provide adequate support to gasification of biomass or a combination of coal and biomass. The most pressing near-term research needs centers on developing a fuel handling and gasification system capable of accepting both biomass and coal. Finally, I recommend consideration of a number of important high-risk, high-payoff research opportunities that are not being addressed in the current federal program because they require a longer time frame for execution, and these opportunities are covered in my written testimony. This concludes my remarks. Thank you.
Thank you very much. Mr. Hawkins.
Thank you, Mr. Chairman. Members of the subcommittee, thank you for inviting me to testify today. As has already been noted by several members and by witnesses, we are facing as a nation, and indeed as a planet, two large and growing threats, oil dependence and global warming. It's critical that we address these together in designing strategies for energy and environmental protection. Now, the supporters of coal-to-liquids technology claim that the fuel can both reduce oil dependence and can have greenhouse gas emissions that are as good or better than the petroleum products that they replace. Well, those are claims, and this is the Science and Technology Committee, and good science requires that claims be analyzed. The problem is that these claims have not had the scrutiny that is required given the attention that Congress has been paying to this matter. Certainly, the objective analysis of the total life cycle impacts of this approach of coal to liquids to addressing these twin problems compared to other alternatives have not been presented to Congress. And there's certainly no basis for the mandates and incentives that have been fuel-specific that have been voted on in both bodies of Congress. Fortunately, neither has been fortunately in our view, because to do so would be making a mistake given the lack of analysis that has been provided about the merits of this approach compared to others. So let's take a look at a number of these issues in the time that I have. First, as to greenhouse gas emissions, the most authoritative analysis by the Argonne National Labs indicates that without carbon capture, coal-to-liquids will produce more than twice the well-to-wheels greenhouse gas emissions of diesel fuel, and even with 85% capture of carbon from a coal-to-liquids plant, the resulting emissions will still be about 20% greater than conventional diesel fuel. Now, let's compare this to alternative ways of using coal to back out oil, because there are alternative ways. One of them is with plug-in hybrid vehicles. We can have coal, turn it into electricity. If we do that in a modern plant that is equipped with carbon capture and storage, we can back out about twice as many barrels of oil per ton of coal as compared to the coal-to-liquids technology, and we can do it with 1/10 the greenhouse gas emissions. These are facts that haven't been presented to the Congress, and it ought to be evaluated before we move forward with what is likely to be a suboptimal approach.
The problems that I want to turn to next are problems of scale. In order to make a difference on oil security, a coal-to-liquids industry has to be huge. In order to cut oil consumption projected for 2025 by 10%, that requires something on the order of 470 million tons of additional coal mining in this country. That's a 43% increase in today's level of coal mining. Unfortunately, today's level of coal mining is associated with a lot of environmental damage. We need reform of our coal mining practices before we contemplate that magnitude of an increase in coal production. The water use is another issue, and I believe that Dr. Boardman will address it. But water use for coal-to-liquids technology is large indeed, perhaps as high as 12 gallons for every gallon of fuel produced. Then there's the impact on the coal market itself. Congressman Bartlett's opening statement notes that the reserve estimates for coal, while apparently large, are themselves uncertain. And if we increase coal production in order to back out oil through the liquids coal market, the impacts on recoverable reserves could be profound. In my testimony, I point out that if we tried to back out just 1/3 of oil imports starting in 2030, that by 2050, 40% of today's estimated recoverable coal reserves would be gone, and by 2080, they'd all be gone. If we tried to do more than 1/3 of oil imports, then the impacts would be that much greater. There's also the impact of carbon capture and storage. This technology would add a large new demand for reservoir space, and as Dr. Bartis has noticed, we already will have a challenge with deploying carbon capture and technology for the electric power sector. So we need to think about that. In conclusion, let me make a recommendation. Rather than mandate a fuel-specific approach or adopt incentives for a fuel-specific approach, we need a fuel-neutral approach. We should have incentives and performance standards that reward entrepreneurs who deliver alternatives to oil that do the best job at backing out oil and do the best job at cutting greenhouse gas emissions. And that's the approach we recommend. Thank you.
Thank you, Mr. Hawkins. Dr. Romm.
Thank you. Thank you, Mr. Chairman, members of the committee. Appreciate the opportunity to share my views on liquid coal. I will address two key questions. First, should Congress promote coal as a transportation fuel? And second, if Congress does, will people actually drive their cars with liquid coal? I think the answer to both questions is decidedly no. Congress should really promote only those technologies and strategies that provide significant net societal benefit. Liquid coal does not provide net societal benefit. Worse, it will actually cause societal harm. Liquid coal would increase greenhouse gas emissions, use up increasingly scarce water supplies, and divert hundreds of billions of dollars from crucial clean energy solutions. We simply have run out of time to waste money and resources on liquid coal because global warming is happening faster than scientists had warned. Sea ice loss, ice sheet loss, temperature rise, sea level rise, hurricane intensity, and expansion of the tropics, all of them are happening faster than scientists expected. We all want to avoid catastrophic warming, such as 80-foot sea level rise, and that means limiting future warming to 2 degrees Fahrenheit, and that requires mandatory cuts in greenhouse gas emissions of 60 to 80% by 2050, as many bills before Congress would require. And it certainly doesn't make any sense for Congress to pursue, on the one hand, reducing fossil fuel CO2 emissions dramatically on the one hand, and then on the other hand, significantly promoting it with coal to liquids. It is true that carbon dioxide emissions, that as Dr. Hawkins said, carbon dioxide emissions from coal to diesel are about double that of conventional diesel. It is true that you could possibly capture the carbon dioxide and store it underground permanently, but that will make an expensive and complicated process even more expensive and complicated, so it seems unlikely for the foreseeable future. I would also add that there's no evidence whatsoever that this country is at all serious about carbon capture and storage. If we were serious about carbon capture and storage, we would be doing decidedly different things. We would have a price for carbon dioxide, without which there will be no carbon capture and storage, and we would start identifying and certifying repositories for carbon capture, for carbon storage, which we haven't even begun doing. I would also add, as I explained in my testimony, that using carbon dioxide for enhanced oil recovery is not sequestration. Why? Because the carbon dioxide squeezes more oil out of the ground. You then burn that oil and you release the carbon dioxide again. So you haven't accomplished anything. I would also add, and this is important, that when you're done with the carbon capture and storage, if you happen to do it, you're still left with diesel fuel, which is a carbon-intensive liquid fuel that will release its carbon into the atmosphere once it is burned in an internal combustion engine. We're going to need to reduce diesel consumption and all liquid petroleum consumption 60 to 80% by mid-century, so we don't need to figure out ways to increase it. The future of coal in a carbon-constrained world is not liquefaction plus carbon capture and storage. The future of coal is electricity generation with carbon capture and storage, since that is carbon-free. A 2006 study by the University of California found that a significant use of coal to diesel could increase annual emissions by 7 billion tons of carbon dioxide for several decades. That is more than current U.S. carbon emissions and would certainly be fatal to any effort to avoid catastrophic warming. Instead of promoting liquid coal, Congress needs to address the climate problem by establishing a cap on emissions that creates a price for carbon dioxide. What would be the impact of that cap when you ultimately put it in place? The U.S. Energy Information Administration has actually done a number of studies on this. In one analysis, EIA modeled a carbon dioxide permit price reaching only $14 in 2030, a relatively low price, considerably lower than the current price for carbon dioxide in Europe. Yet this low price reduced projected liquid coal production by 85% in 2030. A second EIA analysis showed that even a moderate price for carbon dioxide wipes out all projected liquid coal plants. So Congress is going to be passing laws in the next few years that are essentially going to render all carbon capture, all liquid coal uneconomic. Coal to liquid is just a dead end from a climate perspective, and from a water perspective too. You've heard what Dr. Hawkins said. We're in a world that's facing mega droughts and chronic water shortages from human-caused climate change. And in fact, water demand is one reason chronically water-short China has raised the capital threshold for liquid coal projects in an effort to scale back growth. Time has simply run out in the race to avoid catastrophic warming. We no longer have the luxury of grossly misallocating capital and fuels to expensive boondoggles like coal to liquid. Liquid coal will not have a future in this country, no matter how much money Congress squanders on it. I think Congress should not allocate significant funds to liquid coal R&D or other measures to promote liquid coal. The future of coal in the carbon-constrained world, again, is in the form of electricity generation with carbon capture and storage. And as Dr. Hawkins said, if coal has a future as a transportation fuel, it is with plug-in hybrids running on zero-carbon electricity generated from coal with carbon capture and storage. Thank you.
Thank you, Dr. Romm. Now, Dr. Boardman.
I am honored to be invited to contribute to the discussion about the benefits and challenges of converting coal into liquid transportation fuels. I have submitted a lengthy testimony to you, but time will not permit me to draw your attention, but only to a very few of the most salient points in that document. My remarks are based on my personal professional knowledge and do not reflect the views of the Department of Energy. Please direct your attention, if you would please, to the drawing in the lengthy document on page 6 of my testimony, which shows the life cycle of carbon obtained from biomass and coal when it is utilized to produce synthetic fuels, electric power, and chemical products. This figure depicts the plant that Bard Energy is developing for a site in Ohio. Bard Energy and the Idaho National Lab entered into a cooperative research and development agreement to study a coal-to-liquids plant similar to the figure you are viewing, using the majority of coal with a smaller portion of biomass. Now please turn your attention to the summary table on page 5. The top row shows the amount of greenhouse gas released when transportation fuels are produced from Arabian crude. The second row shows the greenhouse gas emissions calculated by DOE Nettle for a hypothetical coal-to-liquids plant. The third row shows the greenhouse gas emissions calculated by INL for the Bard Energy Ohio project before any controls for greenhouse gas emissions are implemented. The remaining rows show various levels of greenhouse gas reduction that can be attained by implementing carbon capture and sequestration and by co-feeding only 30% biomass to the coal gasifier. As you can see from this table, it is possible to reduce greenhouse gas emissions by up to 46% below comparable crude emissions
when the coal-to-liquids plants are operated in this manner. I wish to leave you with 3 factual points with respect to the exemplary Bard Energy plant design. First, gasification in coal and biomass blends is technically feasible and commercially proven and available for use today. I have over 20 years of experience. My PhD is in gasification and combustion. I have performed research in this area. Second, gasification of biomass with coal is the technically best method for extracting the available energy from carbon from the biomass to produce transportation fuels and other chemical products. I repeat, it is the technically best method of extracting the energy and carbon from that biomass. Third, this technology is ready for first-of-kind facilities in the United States, just as it is currently being applied in other nations, except that in America, engineering, ingenuity, and the will to control greenhouse gas emissions can provide a beacon to the global commons. Let's turn our attention to the concerns about water that has been brought up. On page 12, I present a drawing showing the demand and discharges of water for a representative coal-to-liquids plant. A large amount of water is needed, as has been stated, to produce hydrogen and to provide process cooling throughout these plants. Evaporation losses in the cooling tower can be significant. As much as 10 to 15 barrels of water per barrel of liquid product will be required unless standard operating practices are changed. Gas-to-gas coolers and closed-loop heat recovery cycles can be deployed to reduce the water demand to as little as 3 to 5 barrels per barrel of liquid product. The technology exists. It is a matter of cost, benefit trade-off, and a will to implement these changes. In my written testimony, I will draw attention to the potential of using coal bed methane wells produced water to supply coal-to-liquids plants. For example, I project the possibility of using coal bed methane water that may be produced in the Wyoming Powder River Basin to support the production of 4 million barrels of synthetic fuels produced over a 50-year period. The water availability may not be the barrier to startup of the first coal-to-liquids plants or those that are built and replicated thereafter. It may simply be the cost-benefit trade-offs required to reduce that water consumption. Again, American ingenuity and engineering can help. I think I'll pass by my comments on suggestions for research that the federal government could support. I think most of my information is in the written testimony, and a lot of that's already been brought up. In the interest of time, I would like to just proceed to my conclusions. I believe the U.S. can establish greater energy dependence using hybrid and electrically powered cars, as has been suggested, while assuring there is an adequate supply of diesel and jet fuels for, please understand, aircraft, shipping vessels, trains, heavy vehicles, and machinery that currently consumes a high percentage of the petroleum derived in fuels in the U.S. A balanced portfolio of clean energy is needed, inclusive of clean coal conversion to electricity, chemicals, and transportation fuels. It is important to national security and climate control that clean coal-to-liquids plants be constructed to establish the experience and infrastructure necessary to establish this industry in the U.S. Thank you for allowing me to speak.
Thank you very much. Now we'll move into the question period, and each member will have 5 minutes. I yield the first 5 minutes to myself as chairman. And Mr. Boardman, Dr. Boardman, let me start with you. In your written testimony, you state that a coal-to-liquids plant could produce or could approach 15 barrels of water per barrel of liquid fuel product from low moisture bituminous coal and 12.5 barrels of water per barrel of liquid fuels for high moisture sub-bituminous coal. How does that water requirement compare to conventional petroleum-derived motor fuel production now?
I'm not sure that I can give you an exact answer, but again, these plants require hydrogen. Carbon is deficient of that hydrogen, and so you need water, at least a barrel of water, to make up the hydrogen needed to formulate the synthetic fuels. The majority of the water, Mr. Chairman, is actually consumed in the cooling towers that are used to cool the intermediate and low-pressure steam. And so in that part of the plant, by that evaporative process of those cooling towers, you lose copious amounts of this water.
Some strategies to change that?
Yes, that is where they need to upgrade the plants to these gas-to-gas heat exchangers, then which would eliminate the duty on those cooling towers. Also, as we progress forward to look at these closed-cycle heat recovery loops that many are working on in the United States, that will also help.
And is there a role for federal research to help ensure that those strategies become effective?
Yes, in that particular area, I think demonstration of some of these closed-loop heat recovery cycles is recommended.
Okay. For both you and Dr. Bartis, you discussed the possibility of reducing CO2 emissions when biomass is blended with the coal during the liquid fuel process, and when concentrated CO2 is separated from the syngas feed and sequestered. What are the technical challenges with combining coal and biomass in order to achieve a significant CO2 reduction target? You want to start, or Dr. Bartis? You start, and we'll go to Dr. Boardman.
The gasification takes place at some 15 atmospheres of pressure or so. So the challenge is getting biomass into that gasifier in a way to go through that pressure change. And then once it's in the gasifier, you want to make sure that it doesn't interfere with the internal workings of a gasifier that's been designed for something else. So I think it's a pretty straightforward process that we have here. I mean, this is not science, it's technology and testing. But I think we need a few test rigs built, designed and built, and we need to make sure that this system works. I mean, we're handling solids, and whenever you handle solids, you have tremendous uncertainties. It's very hard to scale up. So the only way to make this technology truly commercial is to test it at some scale. Now, there is some experience in the Netherlands on using biomass for gasification, but it turns out these are very small amounts, and they're very special forms of biomass. They're not biomass types that are typically would be found in the United States or used. So I think there's a real opportunity here to do something on a very short time scale.
Okay, so again, is there an opportunity and a role for the federal government to play?
I think, if the federal government wants to come in, I don't see the private sector. I mean, there are lots of in my view, there are lots of uncertainties with regard to the future of coal to liquids in the United States, and I just don't see the private sector coming up with a lot of its own funds to move this technology forward. So I think there is a role for the government.
You want to make a quick comment, Dr. Boardman?
Yeah, well, I concur. Those feed injection at high pressure is certainly an issue that can be further developed and improved, springing from the experience in Europe. But I might also mention that when we talk about biomass and coal gasification, sometimes we think that has to be done in the same gasifier. It isn't entirely feasible to do them in two separate gasifiers. These coal-to-liquids plants will require a battery of gasifiers. So it's possible to use already existing and proven biomass gasification technology, both in Europe and developing in the U.S., to gasify the biomass and the coal in two separate reactors, combining that syngas. But again, I think those dry feed systems is probably the area where research focus could mainly be put.
If I continue with my questions the way I'm going to run out of time. So let me digress from what I intended to do and just ask a question that came up yesterday in some discussions with staff on this. In the process, which I'm trying to understand and I do not, I'm told that a significant amount of hydrogen is separated from this. And if that's the case early in the process, why don't we just take the hydrogen and instead of taking it all the way through this entire process to make a different kind of fuel, why don't we use it when we're trying to build this infrastructure necessary to start to distribute? Can someone comment on that for me?
May I take a shot?
Please.
Yeah. Well, certainly, we've looked at the hydrogen economy, and hydrogen of itself is very difficult to transport about. It's very light molecule.
So would it be better for us to put our money into the research to help solve that problem than into the research to take this through all these different stages to get to where we're going? And
I think the hydrogen economy is well in the future. I think that the coal-to-liquids plants are a bridge to that future, and I think that the liquid transportation fuels, as well as synthetic natural gas, are very convenient carriers of that hydrogen.
Thank you very much, Mr. Inglis.
I said to the chairman, John, bingo, it seems to me that is quite the question, is why invest in something that really is sort of like, well, I think when we're comparing cold liquids to petroleum, we're really comparing Pintos and Vegas. Anybody remember a Pinto and a Vega? Some of the staff back here is too young to remember.
Shows your age.
A Vega, well, my family had 3 of them. They had aluminum blocks or something. They fell apart after a while. They were maybe, you know, with it. The Vega may have been better than the Pinto, or the Pinto better than the Vega. But really, when you're comparing coal to liquid and running in a car compared to petroleum, are we really talking about that kind of comparison rather than a really elegant solution that the chairman was just on to? You figure a way to get that hydrogen into that car. The only emission is water out of the back of the car, right? You don't have this. You know, Dr. Bartis mentioned we can deal with the national security issue, and I think that's correct. It seems to me if we use our own coal, we're clearly dealing with national security. We're not getting all the way, which is also fixing the environmental challenge. So the thing that I found interesting about testimony from Dr. Let's see, Dr. Romm said, and I'd be interested in Mr. Wood's response to this, that a carbon trading system would wipe out cold liquids, destroy the economics of it. Is that correct?
Not in our view, because again, the thing you have, I think you had it right with the Pinto and the Vega. You know, we're not talking about coal to liquids being something that competes with hydrogen that is some number of decades in the future. We're talking about reducing our dependence on imported oil with a like thing. So I would look at it from the perspective of the Pinto. I have to build and protect a system for protecting my imported oil resources, versus the Vega is something that I can do here at home while we're working on whatever vehicle we want for the future. As far as your direct question on the carbon trading goes, the products are commodities. We're not talking about a new kind of fuel. These products will compete against the oil-derived products in an open market, and our analysis shows that as long as oil prices remain above a certain level, $50 a ton or whatever, the impact of that carbon will, the carbon tax or whatever carbon regulation scheme will come into place, will wash out in that process. So I don't see it as a death knell at all.
Yeah, Dr. Freerks had a comment about reducing the risk of those price fluctuations. What would you recommend by way of strategies to reduce that price fluctuation?
My concern is that if crude oil drops precipitously, it will wipe out the economic benefits of building CTL plants. And I think the economic value for CTL plants is in the $45 to $50 per barrel range. So we can make those plants pay back their loans and give the investors a good return at a reasonable price for crude. But we need price stability and a collar on the lower end of that price in order to get the investors to be willing to put money into those plants.
Are you talking about a floor on prices, or a floor on crude oil prices?
Yes.
Is that what you're talking about?
Just a guarantee that the prices will not drop below a certain level, which will just ensure the economic viability of these plants in the future, and we are not then dependent upon foreign sources of crude to fuel our economy and protect our...
Dr. Hawkins, you had some different numbers in the MIT study that is mentioned in the charter for this hearing. You said that MIT apparently says that switching or to replace 10% of the fuel consumption, they say, I think it was your number too, 10%. They say that it would take 250 million tons of coal per year. You said, I think, 470 million tons. They say it would require a 25% increase in our current coal production. You said a 43%. You're disagreeing with the MIT study, I guess?
My numbers are taken from the National Coal Council report, and they are aimed at a target of 10% reduction in the year 2025 forecasted oil consumption, which is larger than today's oil consumption. So you have two numbers. One, the larger amount of oil consumption in 2025, which is about the earliest that you'd expect this industry to get spun up to a size where it could conceivably make that kind of a dent, and using the technology efficiency numbers that the National Coal Council used. I don't know what efficiency numbers MIT used.
Thank you. Thanks, Mr. Chairman.
Mr. McNerney, you're recognized for 5 minutes.
Thank you, Mr. Chairman. Thanks, panel members, for coming this morning. This is a set of very interesting testimony, and there's a lot of disagreement I see between the panel members. Mr. Bartis and Mr. Hawkins both mentioned what I think is the very fundamental quandary that we're facing. How do we reduce our dependence on imported oil while reducing the production of greenhouse gases? And our national security depends on this, our economy depends on us, the environment. It's a very difficult, complicated question, so I appreciate the time and effort that you're all putting into it. And it's important to be open-minded about CTL, but I have grave concerns, especially for surface mode of transportation. Air transportation may be a little bit more interesting, but for surface motive, I think we have grave problems. My first question is Dr. Freerks. There are two issues I'd like you to address. The greenhouse gas emissions, the cost and viability. In my mind, I don't see any basis for what it's going to cost to sequester greenhouse gases, and also the technical viability of that process. Is it safe? We don't know too much about that yet, so building an industry, assuming that that's going to be a good process, is very, very risky. The other question is something that's been brought up, water usage. How do you see that playing out in the long run? Water is going to be even more valuable than oil. It already is in some situations. So both in terms of usage and in terms of pollution in when the coal is mined.
Let's first start with carbon capture and sequestration. The coal-to-liquids process inherently captures CO2 in several places in the plant. We gasify coal, and we capture the CO2 from that gasification process. We run the synthesis gas, carbon monoxide and hydrogen, through a Fischer-Tropsch reactor, which in our case produces more CO2 while shifting the carbon monoxide to hydrogen. And we capture CO2 from that part too. So we can capture CO2 quite readily in our plants with no additional cost because the equipment is there for other reasons. Now, the sequestration part of that is a separate question, and we have addressed that in our Natchez plant by teaming up with Denbury Pipeline, who is moving CO2 from natural sources right now to oil fields for enhanced oil recovery. And the amount of CO2 that we produce is equivalent to roughly 1 barrel of crude oil produced for every barrel of FT produced. And although people may argue that that does not net decrease the greenhouse gas emissions because you're just trading CO2 put into the ground for fuel brought up, it does increase our energy security, and we are going to burn that fuel anyways, whether we burn it from imported crude or we make the crude here. It just changes where we're going to pay for that crude. So it's probably better to use our own domestic resources than it is to produce external resources and bring them in. The other question you had was on what? The water use?
Water usage.
Okay. In the Natchez plant, we have Mississippi River water for cooling, so water use is not an issue in that plant. We have looked at designs for plants that are capable of being put in dry climates like Wyoming, and they actually will not use any more water than they produce. When you produce a barrel of crude oil with the Fischer-Tropsch process, you produce a barrel of water, and that water can be condensed and recycled through the process, and you have no net usage of water. And that's an engineering design issue.
So you're saying that you use a barrel of water in the process and then you produce a barrel of water at the end of the process. Is that what you're saying?
You can design the plant such that you are net neutral on water.
Well, yeah,
It is an engineering issue, it is a cost issue, but it can be done.
that seems far-fetched to me. Mr. Ward, you have referred to abundant coal resources. And if we move forward with liquid to coal to displace petroleum for surface transportation, what limitations do you see on the domestic coal resource? This was an issue that was brought up by one of the other panelists. What limitations are there?
There have been two studies completed in the last year, one by the Southern States Energy Board and one by the National Coal Council, that both took a hard look at the availability of coal, and both determined that our coal resources in the United States are more than adequate to accomplish this kind of a scale-up and use the coal resources for transportation uses in addition to electricity generation.
We'll have to study those reports. And you also talked about CTL being a clean resource. And while the end product is clean, clearly, it looks clean anyway. I didn't open it up and smell it, but I didn't want to get it on my suit. But how much waste is produced in producing a barrel of liquid, and how toxic is the waste, and what do you do with it? Not even considering carbon dioxide.
Well, I'm going to defer to one of the scientists with us, but the waste products from from a coal to liquids plant are very similar to what you'd see in an oil refinery. You've got a gasification slag product, which is a solid product, which is also very similar to the coal combustion products you have from a coal-fueled power plant, the residual solids. They are non-hazard. They're classified non-hazardous wastes in this country.
Having been involved in the intimate details of such a design and seen one on the Bard Energy project, I can't comment to that. It is the ash product coming from the coal and the biomass that might be used. There will be some air emissions discharges. Those will be relatively clean because this process takes out all of the toxic metals in that coal, the mercury, arsenic, and other things, as well as a lot of the unburned hydrocarbons. So you basically may be generating some power in that plant, but it's a combined cycle power, very clean on that discharge point. Does have some CO2 in that is opportune to remove in the future. But apart from that, the water discharges can also need to be cleaned up, but conventional technology exists to do that. So on that basis, it is again comparable to a pulverized coal-fired power plant also that has to clean up its water discharges.
You're welcome. Dr. Bartlett, 5 minutes.
Thank you very much. There's an article recently that said that our usual 250 years projection of coal use might more appropriately be just 100 years. That's probably because at current use rates are just projecting from our current use, and we're really increasing our use of coal a bit over 2% a year. If, by the way, you increase the use of something just 5% a year, that doubles in 14 years, it's 4 times bigger in 28 years, it's 8 times bigger in 42 years, and it's 16 times bigger in 56 years. So if in fact we have 100 years of coal, our present rate of increase in the use of coal, if we increase its use just 5%, I think that would be a low figure if we're going to make any meaningful impact, then we're going to run out of coal pretty darn quickly, aren't we? When you mentioned the evaporation of water and how much water it took, that's really a double sin, isn't it? You're using precious water, and it takes a lot of energy to do that. You're wasting a lot of heat doing that. When the president said we were hooked on oil, he was exactly right. We're so hooked on oil that we become irrational when we're talking about alternative energy uses. We're talking about hydrogen. Why don't we just use the hydrogen? Well, you always use more energy producing hydrogen you get out of it. Why wouldn't you just go back to the original energy source and use that? And if you're talking about using coal, why don't you just burn the coal? There is no better way to get energy out of almost any product than simply to burn it. And if you're doing that where you can use the excess heat of district heat instead of stupidly evaporating precious water, then you have a double increase in efficiency. Am I wrong? Doesn't it make any, by the way, and if you want to get a lot of duration from your plug-in hybrid, instead of stopping to refuel your car, simply stop to switch batteries. And you can now drive an infinite distance with a plug-in hybrid, can you not? if I'm not wrong in all of this, does it make any sense to talk about coal to liquids? Why don't we just burn the coal and produce electricity and use plug-in hybrids?
Well, I would agree 100% with that. I mean, I think, you know, electric motors are very efficient. So if you can generate electricity, you can use it very efficiently. And I think plug-in hybrids are the vehicle of the future. I think there's no question that if you take the coal and burn it in a gasification plant and capture the carbon and store it, you would actually have carbon-free electricity. So you'd be running your car on carbon-free electricity. If you do CTL, if you do liquid coal with carbon capture and storage, you're still running your car on diesel fuel. You have not solved the global warming problem at all, but you spent a bundle of money to get you nowhere. So I couldn't agree with you more.
Except that when you burn that coal in those power plants, you need the same water to cool that steam that you make. The process of
I would use that for district heat. All over the world, they place their power production plants where there are people so that they can use the excess heat for what's called district heating. In the summertime, you can simply use an ammonia cycle refrigeration and cool your homes with this excess heat. What we do is really dumb, and we need to stop doing it, do we not?
Yes, and that same steam, though, could be taken off that coal to liquids plant and used the same way. It's the exact same steam. It's the exact same quality of heat.
If I could just add a word about the elephant in the room, and that is energy efficiency. This is the long pole in the tent if you're worried about oil dependence and global warming. We can back out more oil with smarter cars, smarter transportation systems. We can back out more global warming emissions with that, and we can give Americans increased choice. Vehicles, people don't buy vehicles because they burn lots of gasoline. They buy them for the services they provide. And if we have intelligent policies that are designed to deliver vehicles that people want to drive, we don't need price supports for minimum prices of oil. Those vehicles are going to provide value to American consumers, whatever the price of oil is.
I would just agree. I don't think I would agree entirely that plug-in hybrid vehicles are a place we need to go. That energy efficiency is a place we need to go. Coal to liquids is a bridge technology. It's not the ultimate technology. The problem with the problem with plug-in hybrid vehicles is we've got to make millions of them and convince people to buy them and use them. There are no plug-in hybrid airplanes, there are no plug-in hybrid locomotives, there are no plug-in hybrid big yellow machines that build things and long-haul trucks and those kind of things. We will continue to use liquid fuels from those types of things. And one other clarification on the brief discussion on price supports for deployment of coal liquids facilities. I don't think anyone in the industry is looking for that as a permanent solution. When we talk about commercialization incentives, we have a commercialization gap where we need to convince Wall Street that the first few of these plants can be built. So when you're looking at some sort of a mechanism to ensure against price volatility in oil markets, you're only looking at that for the limited purpose of the first few coal to liquids plants so that you can get this industry kick-started. And after that, let the industry compete against oil resources and others to fill that continuing demand we're going to have for liquid fuels while we wait for efficiency and plug-in hybrids to take hold.
What you say about the trucks and the trains and airplanes is, particularly for airplanes, is exactly true. They've got to have a liquid fuel. But a large part of the liquid fuels we use are in automobiles. And we can do something about that, can we not? Thank you, Mr. Chairman.
Thank you, Dr. Bartlett. And now Mr. Costello, 5 minutes.
Mr. Chairman, thank you, and thank you for calling this hearing today. Mr. Ward, I appreciate you making the comment that there are airplanes and locomotives and other road building equipment and other vehicles that have to run on liquid fuel. Both you and Dr. Freerks made the point that the Department of Defense has been a leader in moving to clean coal technology and also to coal to liquids. And There's been some discussion, I think, and some skeptics in the past saying, do you have to modify aircraft engines in order to run them on coal to liquids? And Mr. Ward, I think I heard you say earlier that one is that CTL is not a new kind of fuel, and two is that you do not have to modify existing engines to run them on CTL. Is that correct?
That is correct. You're making gasoline, diesel fuel, jet fuel. Those fuels can be used directly. They can be blended with petroleum-derived fuels. They can be distributed in existing pipelines and service stations. And that's no small issue. When you look at new types of fuels coming into play for the United States, you're also going to not only build the vehicles that run on those fuels, you're going to have to build the delivery systems for getting those fuels to market. Ask anyone who tries to drive E85 in lots of states in this country, where they can find those things. One of the advantages to CTL is that bridge technology is we can put it into the existing pipelines, the existing vehicles, and reduce our dependence on imported oil right now.
So for those who have questioned, do you have to modify, does DOD have to modify the engines? They do not. JetBlue and some of the other airlines are looking at CTL. Dr. Freerks, it looks like you want to make a comment here.
I've been involved with the development of the FT fuel with the Department of Defense for about 8 years. And the only concern that they really have is that they have not seen this fuel in their engines before, so they are testing to make sure that it does work. And so far, all the tests show that there is no modification needed, other than you can get more efficiency out of the fuel if you design the engine to actually run on that fuel. We can run it on the existing engines, but we can actually do better. And even NASA is looking at designing spacecraft to run on the FT fuels because it provides a cleaner way to get into space than many of the other alternative fuels that they have been using. So there are many advantages to this fuel. It's not only just a replacement for conventional fuels, it's an enabling fuel for both the turbine engine and the diesel combustion engine, where we can design the engines to be both more efficient and lower polluting because the fuel itself burns so much cleaner than conventional fuels which contain aromatics and sulfur.
And it's my understanding that the Department of Defense, the Air Force in particular, has just certified a CTL blend to be used for the B-52?
Correct.
And that just took place just a few weeks ago, is that correct?
Correct.
Mr. Hawkins, my understanding from your testimony is that you indicate that carbon sequestration makes sense for coal electricity generation, but not for CTL. I wonder what you believe are the appropriate federal initiatives for developing sequestration use for electricity production.
Thank you, Mr. Costello. Actually, we believe that carbon sequestration or carbon capture and storage makes sense for any use of coal. What we question is using coal to make liquid fuels. We think that a better way to back out oil, if you're going to use coal, is to make electricity with that coal and then use it to make plug-in hybrid vehicles. We think that can deliver more barrels of oil per ton of coal with many fewer greenhouse gas emissions. So instead of, you raised the aircraft issues, we need to look at this as an overall resource, and efficiency driven through plug-in hybrids can free up barrels of oil that then can be available for other uses such as aircraft. So instead of spending lots of money to produce a new fuel for the Air Force, why not look at the U.S. Postal Service, have that fleet converted to plug-in hybrid vehicles? Why doesn't FedEx look at converting its ground fleet to plug-in hybrid vehicles and free up all or a part of the needs for the aircraft that need it?
Dr. Boardman, do you have a response to Mr. Hawkins' statement?
Thank you, I do. Maybe add a new perspective here. When you look at the oil reserves to the production rates, you can look at British Petroleum statistics published 2 years ago that indicated all of North America, if we continue at the rate of production, we'll deplete those reserves within 10 years. And so that means that we've got to look towards, when we're looking at all of the transportation vehicles and the heavy vehicles, our demand for that oil. As that oil depletes and national security risks go up correspondingly, we need to have an ability to generate that fuel in terms of national security, and I think it's important for us to begin to establish that infrastructure now to be able to do coal to liquids, because it does take time to do that. It takes time to build that. It takes heavy equipment and vessels. We don't have that capability nor that experience. So the first few plants could establish that capability, so when those declining reserves do eventually meet up to us, we're prepared to have an alternative for that liquid fuels.
I thank you, and I thank you, Mr. Chairman.
Thank you, Mr. Costello. Mr. Hall, 5 minutes.
Mr. Chairman, thank you. I've listened here and read some of your testimony. I go back to the reason we're here and what we're doing here, and the major duty of a member of Congress, probably one of the major duties, is to prevent a war. And right now today, the major war I see by some of you on the panel there is a war against energy. You're knocking fossil fuels, you're knocking coal. I guess to Dr. Hawkins and Dr. Romm, I'd have to say that I just disagree with you. You're both pushing the fear of global warming, yet you don't have any answer for the cost of it. I just would like to ask Dr. Hawkins if you and the NRDC and Dr. Romm, if you and the Center for Energy and Climate Solutions, and I think this follows the question Dr. Congressman McNerney was asking about. I guess I'd ask Dr. Romm, do you really believe that you ought to tax carbons? Isn't that your testimony?
No. I'd prefer a cap and trade system.
Well, yeah, you prefer to explain it away. Let me read it to you. I think you said, instead of promoting of liquid coal, Congress must address the climate problem by establishing a cap on emissions that creates a price for carbon dioxide. What do you mean by that? If that's not a tax.
Well, taxes go to the government, and in a cap and trade system, the revenue is typically goes to, is circulated in the economy to find the lowest price for avoiding carbon dioxide emissions.
Yeah, but there's a fork in the road there, and either way you go runs the price of gasoline up. Now, please pick that up and explain it. Be practical with me, not theoretical.
Sure, let's be clear. There's no question that if you put a cap on emissions, carbon dioxide will have a price. But you have all these panelists here who are telling you that they're going to capture carbon dioxide from the coal liquids process and bury it. Well, they won't spend a penny doing that unless there's a price for carbon dioxide that gives them a reward for that. Now, I think what Dr. Hawkins and I would say is that if you combine energy efficiency with a switch to cleaner fuels, you have the possibility that the fuels may cost more, but because you're using them more efficiently, your energy bill won't go up. And when I was at the Department of Energy, we did a study with 5 national laboratories which showed that you could substantially reduce the greenhouse gas emissions of the United States of America without increasing the nation's energy bill. And that's what our goal is. But there is no question that the price of carbon-intensive fuels has to go up. If the price of carbon-intensive fuels doesn't go up, why would anybody use less of them? So yes, we are I'm certainly in the camp that global warming, and this is a science and technology committee, and the scientists of the world have spoken earlier this year in the Intergovernmental Panel on Climate Change.
Why do you express all your fears about global warming, though, and you never set forth a way to pay for it? Now, you yourself know that China's not going to do anything but increase the intensity of the damage to the air. And yet take all of our jobs over there, and they're not going to pay 15 cents to help our companies, our energy companies, set forth energy to us at a decent figure. Neither is Russia, neither is Mexico, neither is India. And going down the road, why would you set forth the great fear of global warming right now and not be pushing for technology like coal to liquids, like we've suggested here, and use the abundance of coal that we have in this country to offset the fear of terrorists that threaten us? And it is a national security issue.
Well, I'm a big fan of reducing oil consumption. I wrote an article entitled Mideast Oil Forever. I think it's just important to understand that there's no point in addressing the energy security problem in a way that makes it harder to solve the global warming problem. I don't think there's any question that the scientific consensus on global warming is clear. We have to reduce emissions, and I think there are a lot of bills before Congress that would do just that. Coal to liquids does not address the global warming problem.
In any way?
In any way whatsoever, no, because you're left with diesel fuel, even if you cap it.
Oh, global warming? Oh, no, I agree with you on that.
Okay. Then we're in agreement.
No, we're in great disagreement. Let me ask you and let me ask Dr. Hawkins how he and NRDC feels, and you, Dr. Romm, how the Center for Energy and Climate Solutions feel. Let me ask you a simple question. It doesn't mean to be an insulting question, because I know your answer is going to be yes. Do you believe energy security is important? Your answer is yes, isn't it, for both of you, of course. So if using carbon capture and storage technology can give CTL a better life cycle, greenhouse gas profile than imported petroleum, and a much better performance in the area of criteria pollutants, why wouldn't the NRDC support this, and why wouldn't the Center for Energy and Climate Solutions support that?
The question, Mr. Hall, is not whether we support backing out oil with domestic resources. We do. What we're trying to urge this committee to look at is what is the best way to do this. We've raised a number of questions about why we think coal to liquids is not the best way to back out oil. It's not the best way to use coal to back out oil. These are questions that if you don't look hard at them, you're going to make mistakes, and those mistakes are going to interfere with the objective of getting energy security, and they're going to hit American taxpayers with bigger bills than they need to pay. Those are the questions we're asking you to take a hard look at.
Okay, if you're opposed to CTL, do you support more domestic production of oil then in order to help our national security and decrease our dependence on foreign oil?
Well,
it's all fossil fuels, isn't it?
We have supported enhanced oil recovery because we do think that it's better to get additional barrels of oil out of already producing fields than it is to go into either unsecure areas of the world or go into pristine areas. So, like
drilling on ANWR and in the Gulf and offshore Florida.
We think that
do you recommend that?
We think there are a few places.
Yes or no? Do you recommend that, sir?
We do not recommend drilling the Arctic National Wildlife Refuge. We oppose that. We do support drilling in the Gulf of Mexico, where existing production is doing just fine, thank you. And we support a wide range, which is outlined in my testimony, of producing resources, both U.S. biofuels resources, as well as I'll repeat it again, efficiency can deliver more barrels of oil equivalent than any other tool in the toolbox. And I would just state, American consumers don't value barrels of oil, they value mobility. And if you can deliver that mobility with smarter cars that use fewer barrels of oil, then we are better off from an energy security standpoint, and we're better off from the standpoint of our wallets.
Last question. You advocate the use of plug-in hybrids. Do you therefore support the construction of new coal-fired electric generation plants? Or I support nuclear-powered electric generation plants. Do you support those to add a lot needed generation to the grid?
We think that new power plants should be designed to be the cleanest possible power plants. We are not picking technologies for new electric power plants. We just did a research report with the Electric Power Research Institute. We will need additional electric power capacity. We think we can do a lot more on renewable wind and solar electric sources, and we're really pleased that the state of Texas is doing such a great job on wind-powered electricity. It's growing faster than any other source of electricity in Texas, and your state is a real leader in that area.
Yeah, you're talking about 2% of the energy. That's a big deal. Actually, ANWR, when you oppose ANWR, I guess it's because it's so pristine and you want to save it and don't damage little ANWR. It's just 19 million acres up there, and the bill calls for drilling on 2,000 acres, and it's equivalent. I'll be practical with you, not scientific. it's equivalent to saying if you take a football field and you lay a dollar bill down in the end zone, you run the whole field. That's outrageous, and you know it. I yield back my time.
Mr. Wilson, 5 minutes.
Thank you, Mr. Chairman. Gentlemen, thank you for being here today. I have a special interest in this because, as Dr. Boardman talked, the proposed BART Energy project would be in my district, where we also, Mr. Hawkins, we make lots of electricity along that Ohio River corridor in Ohio from Youngstown down to Cincinnati. What we're trying to do is to find alternate ways to be able to make ourselves less dependent on foreign oil. And I believe in not only because of the fact that we have the proper things to bring it together in our district, we also have the need that we need in our country. And to know that this fuel can be burned as clean or cleaner than what we're burning, and we're not paying for it to a foreign source, I think is very important. One of the things that Mr. Ward talked about that I thought was extremely important for everyone to understand and conceptualize about this is that the CTL is actually a bridge technology. And I wanted to ask you, Mr. Ward, if you would continue on that, expand on it, because I think it would answer some of the questions where folks were saying that we only have coal for 100 years. Well, 100 years is a long time. But if you'd talk on that as to what really is the effect of CTL.
Well, again, I think it's important to remember that we're trying to deal with two issues at the same time here, one being an energy security issue and the other one being a climate change issue. And they're both crucially important. And I think some of the tension in this debate comes when we try to put one over the top of the other. What we're talking about with coal to liquids is using a domestic resource that we have to replace a resource that exacts a tremendous cost on our nation and our economy to protect the access to it in other parts of the world, largely from places where people don't necessarily like us. So it is to take nothing away from the need to do more for energy efficiency, to do more for new types of vehicles. The hydrogen economy, if we can ever get to that, would be a wonderful place to be. But the reality is, our production and refining base today is at its maximum level. Our refining facilities are located in places that are vulnerable to terrorist attacks and to natural disasters like hurricanes. We need to do more to use the resources we have and expand and diversify our resource base for producing the fuels for the vehicles we drive today.
And I think it's going to take, and please, anyone of the panel, if you will, please disagree with me if you do, but I think it's going to take the implementation of all these things, not just coal to liquid, excuse me, not just wind, not just solar panels, but all of them. And the sooner we realize that and begin moving in that direction, I think the better off we're going to be. One of the points that I would want to ask to the panel is if coal to liquid is not the right way to go, why are so many other countries doing it and some becoming very successful with it? Does anyone have any comment on that?
Well, let me just take a quick one and point out, for instance, China is a country that attracts a lot of our interest. China faces many of the same dynamics that we do. They are dependent on foreign sources of oil. In fact, they're dependent on the same foreign sources of oil that we are. And they're making some critical decisions right now as to what they need to do. They can invest billions of dollars to build pipeline capacity to bring more foreign oil from the coasts to their interior where the cities are growing, or they can invest those billions of dollars in developing the coal resources that they have in the interior for making liquid fuels from their own resources. They are, in fact, investing the billions to do more with the resources they have. I think that's, the Philippines, India, a number of the growing Asian countries are making similar types of decisions, and it's easier for them to do it because the government has a more direct role in building those first plants. The problem we face here in the United States is that we go to Wall Street and ask for the money, and until we get the first few plants built, there's a tremendous resistance from the private capital markets. Everybody wants to be the first person to build the fifth plant. So.
Have we not, Mr. Chairman, have we not always in America, though, the thing that has made us above and better than most others is the fact that we do provide the technology and we are able to move forward with the challenges we have because we're willing to take the risks and to do what's responsible.
Well, we're providing the technology that the Chinese are using right now
Exactly.
to develop their CTL resources, so.
So yes.
If I could
Mr. Hawkins.
just comment, again, the debate here is not about providing incentives for technologies to get the job done. The question is, why pick a fuel and why pick a process when you're providing those incentives? Why not focus on the objective? If the objective is to back out oil, then give incentives that are open to all comers for processes that back out oil. If the objective, as we believe it needs to be, is to cut global warming emissions, then provide incentives for technologies that do a better job of that. Focus on the objectives. Don't try to pick the technology or fuel winner.
If I could add 2 points. One is China appears to be scaling back their effort on CTL. And I posted on my blog at climateprogress.org a couple of articles that go to that very point. So I think it's important to understand that CTL is not taking over the planet. I think the other important thing to understand is we have $70 a barrel oil. We do not have any CTL plants in this country. Now, people tell you we could spend money to solve the water problem, make the plants more expensive. We could spend money to capture the carbon. No one's building these plants because they cost $5 billion for 80,000 barrels a day. They are phenomenally expensive plants. They are not profitable at current prices of oil. They are going to be infinitely less profitable if you try to deal with their water and their CO2. So it doesn't make a lot of sense for the government to push CTL down the throats of consumers. They don't make a lot of sense economically or environmentally.
If I could comment on that, Mr. Chairman. I think there's two things in play there. Number one, why are we looking for coal to liquid? It's simply because we have an abundance of coal. And secondly, I believe it's very important to realize that this technology is something that is going to, if we are paying $70 a barrel now, who's to say we're not paying $170 a year from now? And so what this does is we get these plants up and going, it gives us some balance in which we need badly right now. Mr. Ward?
Can I comment? I want to, I'm a little concerned because what I hear is a lot of second guessing of the marketplace here and what works and what doesn't work. The fact is that we have a technology. It's one of the few choices that we have that's ready now. It's called coal to liquids with Fischer-Tropsch. The problem with that technology is that we've got a concern with global warming, and we have not proven that we can sequester the carbon dioxide emissions. That's a fact. That fact says that we should not be putting together any incentive that says that promotes a large coal to liquids industry. Doesn't mean that we shouldn't invest small amounts of money to get some early experience. And there's a big difference between us, the government, trying to pick winners and rather than look at coal to liquids as the first, as insurance, a small insurance policy. The other thing I wanted to say is that I think it's very important to endorse what David Hawkins has said, that we focus on objectives and not on technologies. There's too much willingness among all parties, it seems to me, to try to pick this particular technology or that technology. The two objectives are back out, import less oil or use less oil and put out fewer emissions of CO2. And dressing one or the other dressing one doesn't mean you're going to fix the other one. For example, we know that if we pass legislation that puts a premium on carbon emissions adequate to sequester emissions for electricity production, which is about $30, I believe, a ton of CO2, according to the MIT study, that's only going to raise the price of gasoline 35 cents a gallon. That's just not enough to cause anyone to use less petroleum. So we need to think of disincentives or incentives. I prefer disincentives because they encourage efficiency and conservation, but we need to think of broad-based incentives and disincentives for using less petroleum and for reducing carbon dioxide emissions. That's the real key here.
And if I may, Mr. Chairman, I think that's wonderful in an ideal world, but we're in a real world, and it's a situation where we're going to have to do something with our energy dependence, and we need to be moving on it now. Thank you, Mr. Chairman.
Mr. Hill, 5 minutes.
Thank you, Mr. Chairman. Gentlemen, I'm not a member of this committee, but I'm very interested in this whole issue because I am from Indiana, which produces a lot of coal. One of the things that I've learned in my years in Congress, it's very hard to determine what the facts are in this city. And I've been listening to you for an hour now, and I still don't know what the facts are. So maybe we can clear up some of these things. Mr. Ward, you said that coal to liquids is cleaner than the way we produce gasoline today from oil.
Yes, sir. The fuels that result from the CTL process are cleaner than the fuels that come from a traditional petroleum refinery.
Mr. Bartis, you said coal to liquids will produce 20% greater carbon emissions than oil.
They will produce much more than 20%.
According to the Argonne National Labs. So who's right here? Are you right, or is Mr. Ward right?
Well, no, there's two different issues. We're talking about two different things. One is the performance of the fuel after it's produced. The other issue is what are the greenhouse gas emissions in producing the fuel. If you look at a total fuel cycle basis, our calculations, and we've been very careful with this at RAND, our calculations show about 2.2 times as much as conventional petroleum. That's with nothing, not doing any carbon management at all, just putting all the emissions into the atmosphere.
So, Mr. Ward, how do you respond to
that? 2 ways. Number one, we need to separate the pollutants in fuel, sulfur, NOx, particulates, the things that make people sick, from the greenhouse gas, which is a climate change issue. On the pollutants issue, there is no question that the CTL fuels are much cleaner than the petroleum fuels that they're replacing. On the greenhouse gas climate change issue, if you capture and sequester the carbon during the manufacturing process, you can make those CTL fuels on a life cycle basis be no worse than the petroleum that they are replacing.
Okay, so someone said that the technology as relates to carbon sequestration is not here yet.
I would disagree with that, sir. The largest coal gasification plant in the country is in North Dakota, Dakota Gasification. It's 30 miles down the road from a coal to liquids plant we're looking at building. They capture and sequester their carbon for enhanced oil recovery. All of the coal to liquids developers I work with in the United States are planning to capture their CO2 and sell it for the purposes of enhanced oil recovery. You know, as we look at needing to move to carbon capture and storage for the electricity generation sector, I think we would be missing an opportunity. Here is the CTL industry that is willing to embrace and deploy carbon capture and storage technologies in a large scale right now. These are the demonstration projects where we're going to learn the things we need to know so that we can go back and retrofit carbon capture and storage onto our existing base of electricity generation that produces 50% of the power in this country.
Okay. So let me switch then to what Congressman Bartlett has said. Are we going to run out of coal soon if we increase production by 5%?
I do not believe we are. There's some noise on some newspaper article that appeared recently that was looking at known pieces. One of the things about coal that is similar to what it is about oil is you need to look at what the surveys are based on. Are the surveys based on the exploration that has identified the fields that are fully characterized, or are they based on what we know is out there and haven't gone looking for yet because there's no reason to? The studies I referred to earlier by the National Coal Council and the Southern States Energy Board have both identified more than ample coal reserves here in the country to support both electricity generation and transportation fuels.
Then why isn't this happening, Mr. Ward? I mean, if it's a no-brainer, why is it not happening?
Well, it will happen, and my my position is that you will see a coal to liquids industry in this country. The question is how fast. The $70 oil price issue came up a minute ago. If my coal to liquids plant was running today in a $70 a barrel oil environment, I would be making good money with that facility. The question is, when I go to Wall Street and say, please loan me $3 billion to build this plant, look at how good it is at $70 oil, they say, well, what is the oil price going to be in 5 years when you're paying back the loan after you build this?
So what should we do?
What we should do on the commercialization side is put in place a limited number of deployment incentives to take some of that oil volatility price risk. And there's 2 or 3 different proposals floating around on the Hill now that could do that. But for the first 2 or 3 plants, or 4 or 5, but pick a number, plants, alleviate that oil price volatility factor so you can get those plants running. Then when you go to build the 4th and 5th plant, the people in Wall Street have something to look at. You've got a facility working. These, we will get a coal to liquids industry. Oil keeps going up. It gets to $100, $120 a barrel. People are going to start building these things anyway. You can let it go that way. But that does nothing to address the energy security issue of reducing your dependence on foreign oil before we face another crisis.
Well, my red light's on. I've got like 100 more questions, Mr. Chairman, but I'll let it go at that. Thank you.
Mr. Matheson, you're recognized.
Well, thank you, Mr. Chairman. Mr. Ward, I want to ask you a question first. What do you feel is an appropriate level of environmental performance for CTL facilities that should be met in order to achieve some type of federal financial support?
I believe that the reason for pursuing coal to liquids is as a bridge strategy to help us with energy security issues while we develop the fuels and the strategies of the future. Therefore, I believe if a coal to liquids facility can produce a fuel that is cleaner than the petroleum fuel that it replaces from a pollutant standard and is better than the petroleum fuel it replaces from a life cycle greenhouse gas standard, that should qualify for deployment type incentives to get these plants built. After that, these plants are going to be subject to the same regulations or regulatory regimes, whether it's a carbon tax or a cap and trade system or whatever this Congress ultimately enacts to meet our greater goals of dealing with climate change. These plants will also be subject to future reductions to meet that system. And we will do those things through some of the technologies that have been discussed today, like biomass co-firing and other technologies that are out there. But to qualify for deployment incentives, if what we're trying to do is improve our if what we're trying to do is improve our energy security, what's wrong with a standard that says as long as you're not going backwards, you qualify?
Let me also ask you the question about, we've heard a lot in context of coal to liquids about using biomass in connection with the coal for making liquid transportation fuels. Where is this technology in terms of its opportunity for commercial application now?
And that's really an important question for this committee, where you're looking at where might research dollars be spent. Coal to liquids with carbon capture and storage for enhanced oil recovery is something we can do today. They're commercially available technologies. They're commercially financeable technologies if we can deal with oil price risks. The biomass co-gasification, biomass co-firing, that's earlier in the scale. That's back where we need to do demonstration projects. There's probably some more basic research that needs to be done. Those are areas where we should be spending research dollars, not deployment dollars, in order to develop that technology so that it will be useful in making future environmental improvements down the road.
And what are the environmental benefits of that technology combining the two?
Well, when you combine the two, when you do carbon capture, storage, and utilize biomass strategies, you can now go from a fuel that's as good as or a little better than the petroleum you're replacing to having a liquid fuel that is significantly better than the petroleum fuel that you're replacing.
And just maybe this to clarify what you said, because Science Committee is jurisdiction over research funding, you're suggesting that for this committee that's an appropriate thing to take a look at.
Exactly. My testimony outlined 3 areas that I think are most appropriate for research dollars in this area, biomass being one of them, doing more complete work on setting standards for life cycle assessments for comparing these technologies, to other fossil fuels is a second one, and then continuing to broaden the options and knowledge of carbon sequestration activities outside of enhanced oil recovery is the third.
Okay, I appreciate that, and I'm sorry I was not here at the start of the hearing, and wanted to welcome Mr. Ward, who's from Utah. I wanted to would have introduced you if I was here at the start of the hearing, but I didn't.
That's okay. You would have said something disreputable.
Just one last question I'll throw out to any witness on the committee in terms of the carbon capture and storage issue. And it seems to me that these are, CTL and CCS are both sort of in play right now. Can anyone give the Science Committee direction on the difference between the different commercially available forms of carbon capture and sequestration and the types of research that this committee ought to encourage to help enhance policy support for different types of carbon capture sequestration? That's for anybody who wants to answer that.
This carbon capture and sequestration is one of the great challenges of the next few decades, in my view, and there are a variety of approaches to take, but the most important approach in terms of how much it can capture is geologic sequestration, not the enhanced oil recovery. That's significant, and it's good for the first few CTL plants. It's important that they probably do something like that. But if we want to go beyond that, we're going to have to do something much more significant. Right now, the federal budget on carbon capture and sequestration is about $80 million a year, and that's just way too low for the challenge that's ahead. And there's the critical steps here are to have very large-scale demonstrations. And what's important if you have a large-scale demonstration is that you don't it's not just engineering. There's a tremendous amount of basic science, geological sciences, geochemistry, geophysics that has to accompany any of these large-scale demonstrations. Otherwise, we really don't understand what we're doing. And we have good scientists who are working on this, and this is the real big challenge. It's not just for coal to liquids, for everything.
For everything, yeah.
If I could just add, the Science Committee has to, if it wants to support carbon capture and storage, should develop an accepted scientific process for identifying and certifying geologic repositories. I mean, I would point out, we've spent how long trying to certify one repository for nuclear waste? We're talking about dozens of repositories for carbon dioxide, and we don't have any institutionalized process for how you identify and certify that some repository is going to be safe and permanent.
Dr. Freerks?
I do believe that the Geosequestration Partnership is doing exactly that. They're looking at sites throughout the U.S. I believe there are 7 sites that have been chosen. They're going to sequester millions of tons of CO2 and prove the capture nature of that geosequestration and verify all the issues that go along with that, including any leakage and migration. And there are multiple places where this has already been demonstrated. In Norway, there are 2 major sites that have already been using saline aquifers, and there's Devonian shale and other areas that can store massive amounts of CO2 by the terms in which we're making CO2 right now. We can store CO2 for several hundred years, if not, I think 600 years has been proposed by Dr. Scott Clara of the NETL in their study of geosequestration. So there's a lot of data supporting the sequestration of CO2 for the long term and making it a viable technology for all of the ways that we produce energy through combustion and CO2, and then now it really comes down to how do we capture that CO2 and put it into the ground. Well, coal to liquids offers the best opportunity for doing that because we have to capture the CO2 as part of the process. So there's no inherent additional cost for scrubbing the CO2 out of our concentrated streams, where there would be from coal-fired power plants or from oil refineries or even from fermentation of grains into ethanol.
Well, Mr. Chairman, I see my time has expired, but I do want to thank the panel, and I would suggest as a science committee issue in terms of figuring out what we can do to encourage understanding of carbon capture sequestration. If any of the witnesses want to provide additional testimony that gives direction for us or any ideas, I think that's an issue that this committee ought to take a look at. And with that, I yield back.
Thank you very much. We have passed the UDOL legislation that has to do with carbon sequestration, and obviously there's more that we have to do. I've been looking for a way to get Mr. Hall indebted to me, and I think I may have just found it. I'm going to yield time to Mr. Hall for a question.
Mr. Chairman, I'll ask a question of you. You're going to give us some time to send letters and inquiries to these gentlemen.
You bet we are.
As you may remember, I offered an amendment to the biofuels bill establishing an R&D program looking into a practice that was unfortunately voted down during markup, but you well remember I had a little better luck on offering a motion to instruct conferees, asking the managers on the part of the House at the conference on H.R. 2272 to be instructed, if you remember that, to insist on language prioritizing the early cancer grants to science and engineering researchers for the expansion of domestic energy production and use through coal to liquids. And this passed by a vote of 258 to 167, and most of you guys over there voted for it. I'm going to write to each of these men and ask them if they favor providing grants to our young scientists and engineers to focus on R&D in these questions, and whether or not that's an appropriate or inappropriate expenditure by the federal government and recommendation by this group. And I thank you for your answers, and I thank you, Mr. Chairman. I do owe you heavily.
Thank you, Mr. Hall. I think this has been a very informative hearing. We have maybe it's raised more questions for some of us than we had when we first came in, and obviously we do want the record to remain open for additional statements from members and for answers to any follow-up questions that the committee may ask of the witnesses. I know that I've got some that I will indeed be forwarding out to you. So as we bring this hearing to a close, I want to thank the witnesses for testifying before the committee today. You're excused, and this committee is now adjourned. All your good comments.